For those of you who are back, we're going to continue. All right, so now you want to pull out, what are you going to pull out? Let's take a look here. We're going to go back to bhacker.com. We're going to go back in and make sure you pick out the next one, which is going to be source code examples 2. So if you go into object-oriented programming with C++, and you go into source code examples, now we're looking at programming practice 2. We've advanced. So if you end up programming practice 2, and hopefully you saved that little project we were playing around with earlier today, but we'll just build that one from scratch anyway. We're going to do that one next. But if you open up code 2, if you unzip it and you look at it, you get code 2 in there. You get example number 1, example number 2, and example number 3. Example number 1 is all the initializer stuff. We don't really need it. You can kind of, yeah, let's see if there's anything in here. Okay, there's one thing in here we should probably look at. So in example number 1, you double click on the Xcode project, you get this in here. What I demoed for you was creating instances of objects. You can do the same thing, alloc and init, with all sorts of different types of objects, more than just class objects that you create. And this was what this one's demonstrating for you. So it's just one main program, no other objects in here, but instead we're running an alloc and an init on an NS string. It all works the same. So in here we have NS string, string test, and then string test is equal to NS string alloc init. So we could actually just assign it a value without doing that. And if we do that, we have an object reference, and then it's out there in memory, but it's, you know, not as safe. So what I did before, in the other example, there was a little warning that told me about an NS log and a string that I created, and I put the string in there, and it told me that it was potentially unsafe. That I could, because I didn't really allocate the memory, I'm just hoping the memory's going to be there. I could have actually had some allocation problems. Because the alloc, it actually makes room and it allocates the object, which means it reserves it, puts it into memory, creates a reference to it. Instead of just a guessing game, we actually have a reference to it. So when we use it and then we clean up the space, we don't have to clean up the space. The system does it for us automatically. We have more guarantee that that string is actually going to work. In a small program like Hello World, we don't really have to worry about that, but in a bigger production system, they always say it's better to allocate it, initialize it, and then that way, if we have to make room, we can clean something out of memory and make the room, which is what the compiler is going to do for you, or the runtime engine is going to make the room for you when it allocates and initializes it. If there's no room, and we don't allocate and initialize it, we're taking a random guess that there is room. There may not be room, we're going to have some weird memory problem. It's potentially unsafe. It's not guaranteed that you're not going to get some corruption or somebody else is going to use that memory space. So anyway, so here we're creating a pointer to an NSString object, and the first line here we're going to allocate and initialize it, but it's a string. It's not even an object that we created, but we're treating it the same way. So there's a lot of people that would do this each time. I have a tendency to leave this line out and just do this line here. It works both ways. It will still work. But then you get the message down here that it's potentially unsafe. Well, actually, this is, you know, it's not even going to tell me that it's potentially unsafe this time. So, but theoretically, you want to put that in there to be safe. So this example here just prints out hello world to the screen. It says this is a string in string test. So it's a string object. So in the string object we created, we put the string inside of it. And then we ran the string test : and then we use this @ symbol. So if we have a string and we want to print the string out, we could actually do a couple different things here, and this is the other thing I did as well. I can do this. I can go nslog. It is a string. I can just put the string in here, test string. And then I get this little message and it says, well, what's wrong with it? The string is not a string literal, potentially insecure. Not a string literal, not a string object. It's potentially could not be a string. We don't know what the string is. This is going to convert it to a string with the @ directive here. So it's kind of like the printf, what we're going to print out. Instead of an integer or float, we're printing out a string. So this is an ampersand, oops, this is an @ symbol. And this prints the string out and converts it. Well, that's potentially unsafe because what if it's not a string? Could be an integer, and you're going to have a problem with it. It's just a literal. So, long story short, people do it all the time. It works just fine. But if you want to be 100% guaranteed that what you're doing is going to work and 100% reliable, then allocate and initialize it, and then put a string inside of it and print the string out if you want. But there's no law that says you have to. I just create strings on the fly. So, but maybe I'm not the best example to follow. So that was example number 1. Example number 2 is the more interesting one. So I'm going to open up example number 2. And example number 2 has a simple car. Let's take a look at simplecar.h. Simplecar.h. Now this one is purposely using Coca. You're wondering, you say, well, weren't we using Foundation? We are. Coca's inside a Foundation. We're not using anything else. So if we want to be even more of a minimalist, we can just use Coca. Foundation's got a lot more in it. So, but it's including Coca. But this is really the core library that we're actually using. That's not even the purpose of this example. So the example starts out the way I've been showing you with the data members on the top. So in here we have a car, and we have a definition of a simple car. And in the simple car we have an NS string for a make, NS string for a model, and an NS number for a VIN. And then we have setters and we have getters. And then we put in here this convenience method that I was talking about. The convenience method assigns, it's kind of like a set make, well, set car actually was what we're doing here. So these methods here, set the VIN, set the make, set the model, with a new NS string, NS number, NS string, NS string, and a new VIN, new model, and then set model, which whatever, the parameters that we're going to take in from the command line when we make our car. This is what we just did a few minutes ago with the previous examples. Now in our convenience method, we're going to set the make and the model and the car. We're not using an initializer. You notice there's no initializer in here. There's some people that love to use initializers and some that don't. Not a requirement. You don't have to. Just like a constructor. You see people will use constructors more often than initializers, depending upon what they're familiar with in terms of what they want to do. They call this a convenience method. You can actually consider this a convenience constructor because it's going to set the make, the model, and all the information about the car, regardless. So, and it's outside of the initializer. So I'm going to go into simplecar.m, and I'm going to see the implementation. Do not worry about the release and the make, this stuff here, make, release. You don't have to worry about any of this stuff because this is doing automatic. Release is not for automatic reference counting and not for automatic garbage collection. We have that now. It's an old project. However, it's still working. Objective-C will support old legacy code, which this is. So I shouldn't say old legacy code. It's about a year old. Now, is that old in legacy? To some it is. But this is the simplecar.m, and we have the @implementation, and we have the set VIN method. And to show you what this old legacy stuff is, when we allocated the VIN releases it from memory. It says garbage collect it. So retain says keep it, release says remove it. When we create a pool, we drain the pool to get rid of it. So if we want to create them all individually, we release them all individually. If we do an auto pool, we drain the pool. So it's allocate, deallocate, in better words. So VIN NS number allocate init, which is actually kind of funny because this is actually kind of sort of considered the old way of doing things as well. What's VIN? VIN is a number. So we could have just assigned it a number and taken our chances. So I predict, this is just my prediction, but another year from now we're not going to do alloc and init anymore either. We're getting more like C++ and Java every day. Because the complaint about Objective-C is it's too hard, too tedious. The syntax is just too time consuming. And every release of Xcode and every update of OS X and everything gotten easier and easier and easier and easier. Now we have no more memory management stuff. I'm waiting for the alloc and the init to go away, and let's put those constructors in there like C++ and Java. Why not? Well, let's just turn back into C++ and Java. And that would make everybody's life easier. Because that's why people like Android, is because it's Java. Java's an easier language than Objective-C. But if you've ever tried to do any GUI programming with Android, you'll appreciate this eventually. Because the GUI stuff with Android is pretty hard. Anyway, so let's go back to here. We have a set make, we have a set bin. These are our set methods where we're actually manually allocating a string, and we're initializing it with a string, and that's going to be the new make, and the new make is here. So let's talk about init with string for a second. Yeah?
Are we releasing all the objects before we're allocating them? Don't we usually do that when you're exiting a method? So that
You would, but in this case we're releasing it to free up the memory so we can allocate it again. Because we're going to allocate it again, and we figure, oh, just release the old one, allocate a new one. You're never going to see this in modern day code. This is antique. You're never going to say release, retain. Retain holds onto it, releases it. Here we're just releasing it because we know we're going to, here's Vin. If we had a Vin out there, release it, get rid of it. Why are we going to do that? Because we're doing our own garbage collection? I just figured now we're not even going to allocate anymore in modern days. We're just going to let it happen. See what happens. We're never going to run out of memory, are we? I mean, seriously. Well, we probably would. But we're just trying to be conservative with our memory, so we release it, then we're going to allocate it in the next line of code all over again. When we do this, we actually move it. It gets moved from one location to another because we released it. If we didn't release it, well, we certainly wouldn't allocate and initialize it. We would just set it. And if we were going to set it, what if that space got released? Not safe. What if that space already got garbage collected? Because we have this collector that's running out there whether we know it or not. We don't know what's going to go on with it. It's safer, and that's where the safety thing comes in handy. Safety if we control it ourselves. So in the beginning of Objective-C in this programming technique, everything was under the programmer's control. Now they're not doing very much anymore because it's better to automate it. Huh?
Wasn't that supposed to be one of the advantages of Objective-C, that the programmer has control
It was.
over memory, and now if
it was.
towards the way Java is, then
it was. It's turning more and more into Java every day, or C++ every day. It's lost a lot of its uniqueness. We still need it because it's written for this platform. We can do Java on this platform. We can do C++ on this platform.
That's an Apple proprietary thing, right?
Yeah.
We don't really want it to be open source.
Okay, so not to get into Apple versus Microsoft, but it's really more true the opposite direction. It's Microsoft that doesn't want things to be open source. Apple doesn't have a problem.
Apple. It's Google, Android that is open source.
All right, I have to agree with you. I have to agree with you because in order to get something in the Apple store, you got to go through the Apple Nazis. And the Apple Nazis have got the key. You don't have a key. You aren't given a password. You don't have a key. You're not getting through the gate. And they're going to control who gets through the gate. Huh?
It's quite difficult for developers. I mean,
yeah.
With Android, you can start publishing your apps.
Android, you don't even have to. You just take the APK file and put it on the internet. You can't do that with iOS, which is kind of a bummer, actually. Well, so, I don't know, it's half a dozen or another. We can argue all day about who's more protective over their operating system and who's trying to lock people out. Long story short, they both have their biases, that's for sure. So, and you're right, though, one of the selling points of Objective-C in the beginning was the control that the programmer had. Everything in Objective-C used to be controlled, and it still is, which is interesting. You can still do your own memory management, your own reference counting. You can do everything yourself. The funny thing is, though, is as we're progressing through time, it's slowly not the default anymore. It's slowly just being taken away. So you don't even see the options on any of the wizards or anything to create projects anymore. All the features have gone. All you do is click on next and you're done, kind of thing. In the old days, we had to set more. So anyway, down here, actually to answer your questions from earlier, we have a dealloc on the bottom here. We can run a dealloc and deallocate the object. So I left this example in here only because the one simplecar.m is old school. Simplecar2 is new school. Everything's done the new way in Simple Car 2. This is the old way of doing things. Nobody in their right mind is going to do things in the old way on purpose so that they can get away with the new way, because it's a lot easier with the new way. So with the old way, we had a dealloc, we had an alloc. This project will still run, however. It will still, you can still load it, run it, look at that, the cars get created, there's no messages, but we have all this dealloc and alloc and retain and release, and all this unnecessary stuff that we don't really need in here. All right, so the convenience method is reusing other methods created earlier to set the make and set the model. You notice actually there's a little line return here. You can put them on separate lines. You can write the whole program on one line. It's the same thing as C++. It's just looking for the terminating characters and the opening and closing brackets for scope and for environment. All right, so this is a simple car. It's what we've been working with this morning. With a few different added things in there. So if we look at simplecar2.h, simplecar2.h has got some interesting things in here. We took the make, the model, and the VIN, which we could pull out of here actually, and said, all right, let's do the make, the model, and the VIN with properties. So now with the properties, and we actually have to add this little piece of information. I'm waiting for this piece of information to go away. Because why do we have to retain? Because this is done old school again, with no automatic reference counting. This is an old project. So now we got property, read, write, retain. So we're saying that this object is changeable, and we're not going to garbage collect it. We're going to retain it instead of release, which means when we're done with it, we're not going to put it back into the free memory pool. We're going to retain it. But ignore this for a second, because we don't even need this anymore for the most part. We have an NS-string make, NS-string model, and NS-number VIN. And we have properties over here, which means in the .m file we got to synthesize. Synthesize the make, model, and the VIN. So what this source code is supposed to be showing you is that now with property and synthesize, we have the setters and the getters for everything. And we can use it same way as before, but we don't have to write all those methods out. Now I'm waiting for Java to do that. Yeah?
So because we said read and write, it will generate setters and getters. If
Yep.
you just put like a read, then it will just be a getter.
Yep. Perfect. Yep. That's what it means. So just in case you didn't hear that, the read-write generates both the setters and the getters. The write would just do setters. The read would just do getters. With setters and getters, get the name, set the name. Change it, read it, or write it. One or the other. Because you're changing the property. So by default, if you want both, you're going to put read write in there. And then on the convenience method, here we have set make, we have end model. We can still have our convenience method, but we don't have anything else. This is a very small piece of code here. So what happens with the property declaration, first the compiler will add the declaring properties at the property and then put the attributes in there. So I didn't actually have to have this in here. We could take this out. I just left it in here to kind of compare. We're going to do this or this. If we don't have this, we could take this out completely and it looks like this. And we don't have to worry about that. So, because all we're doing is property and synthesize. Now in main, I'm going to put this back because your example looks like this. So in main, if we look at it, we've got we're just making an auto-release pool. We're doing the old memory stuff. And we're allocating a simple car, and we're using the simple car, and we have simple car 2, so we can actually just put a 2 in here. Simple car 2, simple car 2, and we're going to have a problem because we don't have, is it not spelled the same way? Let's take a look here. Let's see, simple car spelled wrong.
Different in the header.
Yeah, simple car. Oh, it's a header file. You're right. You're right. There we go. Now I get the simple car 2 in there. We'll put the simple car 2 in there. Now we have a simple car 2. So yeah, I had to change the header file. And my car is simple car, so this should actually run the same way. It succeeded. So we have a Honda Civic. Car's a Honda Civic. The VIN is 1, 2, 3. So it's the same functionality, it's the same method, but one's written with the setters and the getters, the other one's with the property and the synthesize. We're going to see the property and the synthesize a lot when we see the iOS, but I wanted you to see it in a non-iOS to get a better feel for it. It's just the data members for the object, and we're creating the auto setters and getters for the data members. Why they call it property and synthesize? I can understand the property, but why they called it a synth, and why you have to do both? It's ridiculous. In the old days, they used to, when you put a property over here, you automatically got to synthesize over in that .m. Now you got to put it in yourself, because you can have a property that's not synthesized. If you don't synthesize it, you don't get the setters and the getters. It's like, well, why are we going to do this anyway? Because you don't want to write out, data members that are private. So it's more of an automated way of creating your data members for your objects, long story short. But that's what the property and the synthesizes are about. We'll see that a lot with the iOS, because most of the iOS stuff is just easier. You're going to write a bunch of methods, or you're just going to property and synthesize. You don't have to write all those methods. All right, so that was example number 2. And example number 3.
See, with the synthesize, right? You can just access behind the screen.
Yeah, you can just access it without it. It's just like a regular old declaration. So, and the synthesize creates the setters and the getters. So if you want those automatic methods to, and we'll see it, the setters and the getters, it's not get name, it's just name. Give me the name. We have set name, but we don't have get name. I like to call it setters and getters, but in reality, it's the property we're setting. So property name, property age, if we're talking about our person, and we set the name, we set the age, and then we just say name. We don't have to go get name, name. If you want, you can actually property and synthesize and then create a set name, a get name as well. Then you have the setters and getters. Well, why would you want to do that? You can just get it yourself. But maybe we'll do that actually when we go back to iOS. Maybe we'll do that. All right, so this one is number 3. And number 3's got a person. Let's take a look at the person here. Got an auto release pool. We're going to initialize a string here. This one's interesting. Forget about all the memory allocation and the deallocation. But this one is an example of initializers. So here we have an NS string, and we're going to string with string. So we have string from float, string with string, string, I don't know, there's so many different varieties of this where we can convert while we assign. So this is an auto way. Why are we red here? Actually, it's getting a good question here. I don't even see this memory here. It's going to say that the string, using string with a literal is redundant. Yeah, I know. But we're going to show you string with string. Let's not fix it because I want the string with the string. So if this was a string with integer, I can go int, string with int, and then give it a number here like 12. And then I can take an integer like an age and turn it into a string. So it's kind of like the toString in Java, where you overload the toString method for an integer, or you do it on another object and it gives you the name and the age or something. It's very similar to toString, but it's not as generic. toString is generally overridden with objects, and it's very generic in terms. This you have to go string with int, and before it said string with string. And then we can do string with float, string with double, string with person, string with employee, or whatever. We create a string out of the object, and we're just doing a method call here, and this method call is actually taking 12, a number, integer number. So just remember we can allocate a string this way if we wanted to. Here's an init with name, name and age. This is the same person as we did before. And then when we're printing it out, this is the other interesting thing. So in this example, we've got person that we had this morning. It's the same person. In here we did an @ directive for private. Do we really need to? No, because it's private by default. So we just put that in there just to show you that you can if you want to. And then on your methods, we have an initializer, we have a name, an age, and we have a method called speak. And then in the implementation file, we have the init with name, And if you look through this example, a little slower pace, you can read all the comments and kind of see what it's doing. But it's the same initializer we looked at before, actually. It just has more comments in it. And then down here we have name, return name, age, return name, age. So instead of the gets, we just have name, age, which is more common, actually. The set name, get name, the setters and the getters terminology came about through different languages and never was adopted by Objective-C. Although I use that terminology, it was never adopted. It's name. There's no get name. But there is a set name. You can set the name, but you can't get the name. Anyway, not very consistent with other languages, but this one is basically just iterating that point as well. And then here's a string that's being initialized with a format. Here's the format. Format is, hi, my name is such and my age is such, and we're going to put the name and the age in there. For those people who are familiar with printf, it's the same thing. We're substituting in placeholders here with the dollar sign, excuse me, with the percent sign. So percent at means put in age. Percent D is for digits. So give me the digit. Age is a number. It's going to give me a digit to put in there. So yeah, not so fancy, but showing it in it with format. So you can init a string, initialize a string with a format. So that's how you're going to convert data into a string. So we'll see. And that one is, I believe, all we needed to do. Let's go back to main for a second. Yeah, there's the other thing in here. Printf. So we decided, you know, we really don't like Objective-C. We want to go back to C. Let's include. And we're going, well, let's import it this time. We can actually change that. We can actually change the import to include if we want to, and that will work as well. So we go include studio.h because I really want to go the C route. And then I want to use printf. If I'm going to use printf, I can convert Barb name, and Barb's the name of the object person that was created here. How'd she end up being 500 years old, I don't know, but that's how she got created. And we can cast it, UTF-8 string. So in other languages we have casting, and the casting is done normally. If we were to cast something, we do it like this. We do string, and then we have the name of the string, and we have my string, or my int. And I'm trying to write C++ code, so let's see how this happens here. Int, string, another is equal to string my, this is C++ code, this is not Objective-C code, but I'm trying to show you an object cast, where we use the format of the opening and closing bracket. We put the data type inside of it to say we're going to cast my int, which is an integer value. So if you had another line of code in the, it said int my int, right? And then I can take my int and cast it to a string to copy it to a string. This is the equivalent syntax, but instead we're running a cast on it in the Objective-C way of casting. And the Objective-C way of casting just puts the data type at the end and says that Barb speak is a UTF-8 string data type. It's a cast to the data type, meaning give me it in this data type. Same thing as we did with the object type casting with string in that example I just gave you. So it's type conversion, type casting. You want to call it type casting. That's a proper way of doing it. So, all right, let's see. I believe it's time to start playing again with iOS. This time, we're going to build it with Scratch. So you're going to get another opportunity. Because what I want to do is kind of go through the pieces that I just gave you and put them together for you. So go ahead and close out whatever project you might have had open. Let's open a brand new project, and I promise to go slower this time. So create a new project. Actually, we're going to simplify this one. We're going to click on the iOS option on the top here where it says Application, and we're going to select a single view application. And I'm not going to do universal right now. I'm just going to make a, we're going to make a phone application, an iOS phone application. So now you guys have to slow me down because I want you guys to do this with me instead of just watching. So let's see what happens. So slow me down, say, hey, 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 wait. I'm stuck. That way I can go around and help people because I want to see you actually do this because then it's better than listening to me. So click on a single view application in the iOS level, click on next. Give it a name. We're just going to call this one, this is really our official hello world. So I'm going to call this one hello class. So organizational name, you might well just put your name in there if you wanted to. I put ITU because I work for ITU. And then on the company identifier, it's usually the URL. So if we're itu.edu, if you're myapps.com or whatever you are, you put in your URL here. Leave this class prefix alone. Change to the device to iPhone. We're going to simplify things. We're not going to worry about multiple storyboards. We're just going to go to the iPhone routes. We're good so far. Click on next. Save the project wherever you'd like to save it. I'm going to put mine on the desktop because I'm going to get rid of it. This one you're probably going to want to keep because we're going to beautify this one. So create. Don't worry about the little button on the bottom. If it said test cases and it was clicked, it was okay. If it wasn't clicked, it's okay. If you did this before, it's not clicked if you unclicked it. The funny thing is it saves all your last selected items get put up by default. So if you unselect something, most likely it's going to be unselected again the next time you go in to use it. Alright, so we are back in an iOS application. So we learned from this morning that we have the model view controller template. I always like to start with the view. We only have one because we only created one type here. We created an iPhone app this time. So I have a main.storyboard and it's just this little screen here. So the screen is actually kind of funny because we have these little icons down here. So one says view controller, the other one says first responder, and then exit. Which I've not actually used the exit very much. The view controller is this view controller file set right here. And we're not going to touch the app delegate today. We'll touch it tomorrow. Because we're just going to build something simple right now. If we had some data that we were working with, we could play around with the app delegate. So we have this phone. It seems to be the long version of the phone. If we click on this view, let's just click on the view. We want this to show up. So you have to click on the attribute inspector, which is the fourth icon over. If this is gone, click on this guy over here to open up the side panel. Make sure you're on the fourth item over. If you're on the fourth item over, you should see view up here. If you click on an item inside, we don't have anything in here yet, but if you click on another item, this will change to whatever it is you clicked on. So let's go and put a label on there. So we've got the ability to make this bigger if we want. We can make it go all the way up, make it go all the way down. Problem is though, when you move it up, you hide everything else. Every time you go back to it, it looks like something different. Down here, you've got a couple of different things. What we want are objects. It's called the object library. So we go into the object library, we drag things and we stick it on. The unfortunate thing is they give you a bunch of view controllers first. Don't do this, but if you wanted to, you can drag another view controller out here. What's that? It's another window. You're like, oh great. So maybe tomorrow we'll go with Windows to Windows. Right now, let's just go with views so we can write some Objective-C code to control the views. But we have a tab controller, collection view, a bunch of items on here. If you just scroll down, you see label. If you don't want to do that, and if you click on label, wow, this is new. It shows you a little read-only text view. You can actually click on the little search bar that's down on the bottom, and I've never figured out how to move the search bar actually. Whoops, now we have different views that we can do. Wow, I don't like that either. Alright, so you just type in label, it brings up label. So that's how I normally do it because I'm interested. So drag a label, stick it over to the canvas. Now if I click on the label, I see label shows up over here. If I click on the view, I see view over here. The hardest thing for people to figure out is how to change everything. Labels over here. It's kind of small, you'd think you'd miss it. Actually, if you're new, you don't even know what you're looking at. You click over here, let's click on it. Nothing's showing up. Oh, what happened with that? You know, and then you go, oh, what's wrong? And then you go, oh, wait a minute now. It's not showing up right. So, actually, that's interesting. Why is that showing up that way? There we go. Huh. Anyway. Actually, good question. Here's our custom view. All right, so I'm going to click on my label. And this is where I was showing you earlier. We can change the properties of the label. We can change the text that's on the label. Your homework after this weekend, if you're interested in learning this, is play around with it. There's like maybe 50 different options you can do to this poor label. And all the other options, I don't know, maybe not 50. There's like at least 20 different things you can do to that label. You can make it shine, roll over. I don't know if it does tricks, but you can do a lot of stuff to it. So I'm just going to leave it there. It's just going to say label on it, but I'm going to make it bigger. And you know what? I'm actually going to make the text a little bit bigger too. So I can see if I increase it. And I'm actually going to change the label on it over here. I could click on it over here and change the label. I'm just going to put here output. If I put output, I see it over here. If I know I don't want an output on the label, I can just take it off. And if I take it off, then I'm going to essentially, oops, there we go. I'm essentially going to be stuck with a label I can't see. And let me take the label off. I'm going to be stuck with a label I can't see. But I know there's a label out there because all I have to do is click around it and I see it. That's why sometimes I take the view and I'll change the view. Like I will, I don't know, change the background color or something on the view. Where did my view go actually? Let's see. I've lost my view control. What did I do with my view? I don't have my view properties anymore. Anyway, I know I'll have a label there. I'm going to leave the label. So I'm going to do the same thing. We're going to do basically redo what we did this morning, but a little slower. So I'm going to drag next here. Actually, because I didn't change the background, I'm going to put output here so it's clear what's going on. Now, because in the code I can set the output to something blank as well. What happened to my view properties? I'm not happy. Anyone know what happened to it? It's gone.
Maybe just click on it, yeah.
I am clicking on it. Normally it shows up. I want to say it's a bug, actually. Don't do this. I'm going to close my project and bring it back up. What did I call it? Hello class. Yeah. Wow. Okay, hold on one second. Hold on one second for me. I'm going to recreate the project. Don't do this. I'm just getting mine back because sometimes that happens actually. The view properties aren't coming back on that storyboard. Not quite sure why. Kind of weird. So this one's going to be hello again. And it's set for iPhone. Okay, good. So if I save hello again, I click on my storyboard. I click and it's gone. Maybe it's my, oh no, I have my little wheels flying. Oops. What's wrong with my view? Hello. Well, that didn't fix the problem, so it must be with something with my settings. So anyway, I'm not going to worry about it at this point. Oh, wait a minute. You know what it is? I hidden. Oh, jeez. This is new, by the way. I don't like this. I hadn't showed it. There's a show and a hide. Why would you want to do that?
Because it was actually an arrow before. I think they changed it to
It used to be a plus symbol before?
like just a triangle.
Yeah. That's what I was looking for, and I didn't see it. The problem that I was having was I went like, actually all you have to do is click right here. If you click right there, which is what I did, I just clicked up there and went, where's my view? And I'm like, I'm clicking on my view, but where's my view? It's not showing up. Because apparently they decided to give you, and that's the funny thing, you see, when you don't put your mouse up, there's a show coming up. Hello, I know. But it's not there, so you wouldn't know that it was hidden, right? Oh my God. That's moronic. Alright, but the point I was trying to make is that if I set the background, which I do here normally, and let me just put my background on green, because all my backgrounds are green. If I drag a label over there, the label's transparent, so the label is going to be on the background. So if I change the background of the label or change the label, so I can come in here and change the behavior or the color of the label, make the label, let's see, attributed. Highlighted, just put it back on plain label. If I take the text away, sometimes I'm able to determine, because of the non-white background, what's on there, especially if I change the background of the label. I'm going to leave it alone though and just kind of work with it from this point of view and just make it say label. Alright, so I'm going to put a text field on here too. So I typed in text. We're going to put a text field in here. We can actually put I could put another label out here too. We're building Hello World, where you're going to type in something. So I'm going to put a little message here. It says, type a message. Hello. Type a message. If I type a message in here, I'm going to press a button, and the message is going to show up on my output. So I can call this guy like output if I wanted to. I want to remember what it was. But that's going to show up on the screen. So I could put, sometimes you put your instructions there and say, hey, type a message. Right here. Type a message. If I did that, then I wouldn't need this one here. So, long story short, put a label and put a text edit out there. At least these two components so we can play around with them. And let's toss a button out there. So when I toss a button out, if I'm in iOS 7, I get a button that doesn't have a border on it. And remember, before I put a label, I put an image on the button. You guys want an image on the button, or we just want the button? Just a button? Okay, we'll just do the button. All right. So we can get the button that says press here. How about press here? So we got a button that says press here on it. When we press the button, it's going to take the text and put it on the label for us. So I'm going to get rid of the side panel that I don't need anymore. And this guy over here maximize my real estate. I'm clicking on the little tuxedo icon. It says Assistant Editor. If I click on the little Assistant Editor, I see, and this is odd because it used to bring up the .h code, but now it's bringing up the .m code. So this is what I was talking about before. In the .m, we're supposed to have the @ implementation and then the @ end. But look at this, I see an @ interface and an @ end. I'm wondering, what is that there for? Why is that there? Because you can put public data in there. So you could use that to wire your components, but it's not really a good idea. Actually, I just pull that out. I remove the @ interface and the @ end because I have the interface. I have it over here. If I click on the view controller.h, I have the @ interface that I want. And this @ interface is inherited from UI view controller. Instead of NSObject, this is a view controller, and I'm gonna use this one. So this is the same thing we do with person, by the way, but instead of being :NSObject, it's view controller. Because this object, its purpose in life is to control the view. So it's this model view controller. Now I can get rid of this here if I want to get rid of the comments and minimize to see what I'm looking at. I have a couple of options actually. So on the life cycle of the app, the first thing we check is to see if the view loaded. And if the view did load, we can do something. So as I was mentioning before, it's kind of like our main. And view did load does nothing more than load the super view did load. So in C++, we go super, and we stick some stuff in there, and we send information back from our current object to the super object. This is the same thing, but this isn't a super method. So this is equivalent, if we were C++, we'd do this, which would send us, usually we use this to overload constructors and stuff, to send a message back. And the message we're sending back is the view did load. The view did load message says load the view, build the object, load the view. And this one here we can actually erase if we wanted to. We don't need it in here, it's not required. But this is a did receive memory warning. If you're going to pay attention to your app and you're going to make sure that your app is running and everything, if you got a memory warning, you can actually, and some apps do this, you can actually tell the user, hey, you're running low on memory. Hey, your battery's going to die soon. Hey, this is going to happen. Hey, that's going to happen. Those are different memory warnings and different warnings. This is one they throw in by default, did receive memory warning. If you don't like it, take it out. You don't need it. Take it out. So it means that I'm not going to warn the user about any memory related problems. So I'm just kind of simplify this down here a little bit. So in the, this is the viewcontroller.m file I've been playing around with. In the viewcontroller.h, I don't have the prototype for the warning. I don't have anything in here. In fact, it's pretty empty to begin with. So what I'm going to do then is what I tried to do before. I'm in viewcontroller.h. I want to wire these components so that I can refer to them as members of this particular view controller class. These are going to be new objects. And the objects I'm going to read and write to these objects, and I'm going to, manipulate the objects. So first thing I'm going to do, and I misspelled type, didn't I? So let me fix that. Type a message. Alright, so I'm going to take my output. I'm pressing down on the control button. And I see this little blue line that comes out of it. And I'm going to drag the blue line. I see the only place I can put it is in between the at interface and the at end. It won't go anywhere else. So I'm going to stick it here. I let go of the mouse button and let go of the control button. And I'm going to call this one the label. So I'm putting a name in there. And the type of this button is going to be a UI label. And for the storage, I'm going to keep it on weak. Tomorrow I'm going to give you a memory kind of thing between weak and strong. I can give it to you right now, actually. In a nutshell, like I said earlier, weak says collect me. Weak is sort of like a release, and strong is a retain from the old days. They should just get rid of it. This should not even be in the interface anymore because we don't have release and retain anymore either. Why do we care if it's strong or weak? We don't care. So right now, just leave it on weak. It doesn't really matter. So now what I have is a line of code that looks like this. This is what we were saying before. So instead of it being read-only, read-write, along with, don't worry about the non-atomic at this point, string, or whatever it's going to be. But this is a property, it's called the IB outlet, so this is a little bit different. A UI label, the label. It's different syntax, different number of parameters because it has a different functionality to it. It's an IB outlet. You don't change anything about it, you just leave it alone. Whatever it dragged over there is going to be whatever you're going to use it in terms of its property value. Did we get that far? We know how to drag and drop? Okay, very good. Now we're going to do the same thing with the text label, but we want the action out of the text. Excuse me, that's not a text label, it's an edit text. The names of this is just mnemonic. So now you're going to right mouse click on that. You need this little menu to show up. The menu that shows up has this thing on the top that says did end on exit. I can drag the did end on exit, and I can put in here the text. You can make up your own words. And then I'll leave it on ID to show you what I like to change it. I'm going to put it on UI text field because that's what this thing is. Now under the event, I can see I have an editing changed editing did begin, editing did end, a touchdown. Like when you touch down into the text field, these are all things that you could possibly do from the text field perspective. Drag up inside, the value could change. I like the did end on exit because it means I pressed return and I exited out of that text field, which means I'm done. I did end. So the wording of that could be a little bit better, actually. But it says the text. It's an IB action. And the IB action is a data type UI text field. So what's the difference between this and NS string or NS integer or any void or anything? It's the same thing. So this is the data type. And the data type is getting, and we know that this is parameter because of the colon. So this is just like saying this, and we can do this actually. I can say NS string. Let's do it this way. And this one's going to be called my method. And it's going to take in an NS string. And that string is going to be called enter text. Entered text. And it's going to say, what's wrong with you? Well, I misspelled something here. I'm going to put another string in there. There we go. So this morning we wrote this. This is a method. It returns an NS string. And it's called my method. So I can call my method on this object here. This is view controller. And it takes a parameter. And the one parameter it's taking is a string. And the string name of the string is called entered text. Well, that's the same as this guy, except for we have the sender guy over here. We're gonna, what's sender? Sender's the event that we get from the GUI. So in here, the text is the name of the action, the IB action that we're gonna perform. And the return type is an IB action, which is kind of weird because people look at this and they go, well, that's not a data type. Well, it is kind of like a data type. So it's kind of like IB outlet's a data type. So it's kind of like IB action. It's a data type, loosely. The name of the method is the text. We're taking in a UI text field sender, which means the text from the UI text field is coming into this text thing. So anyway, I'm going to remove this guy because you don't need this guy in here. I just wanted to write a method that we wrote this morning for person or something similar to it to show you that all this is another method that we're defining. So we're going to do the same thing with the button. So we're going to click on the button. We're going to right mouse click on the button actually. And we're going to pull one of these events. I'm going to take touchdown. It doesn't really matter which one you take. Drag it over. And I'm going to call this one the button. You can pull touch down or touch up inside. That's a popular one. Or touch up outside, touch near it, touch inside it, touch and drag it. All those other things you could possibly do with your finger on the interface. Touchdown is a good one. I'm going to change the data type to a UI button instead of using ID. You can leave it on UI button if you want. Excuse me, you can leave it on ID if you want. No big deal. I'm going to leave sender as the argument because we want the sender, which is the action that's coming from that interface, from that view. Go ahead and press on connect. I have another one. The other one I have now is called an IB action, the button. It takes on a button as a parameter and the button sender. Did I lose anybody?
What was the event?
The event, it can be, if you right mouse click, I chose touchdown. You can use any event that you want. Well, use one of these touches though, because it's when you touch it. The only way we can simulate a touch is with the mouse. It's just like a click. That's a touch. Did we get that far? Do we need a few minutes? We're good? We're good over there? We're all on the same page? Okay, good. I'm just trying to make sure I don't go too fast. Alright, so we're pretty much done. We have our three components, and we can see because we have these three little dots. If we hover our mouse over the three little dots, we see the three little components. So if you got this far, you're almost down the home stretch. So we're going to flip over to the viewcontroller.m file. So I'm going to click over to viewcontroller.m. I see I've got the two methods that were automatically created for me for my IB actions. One of them is the text, the other one is the button. Because over here, stay on viewcontroller.m, but over here, remember we have the IB actions. The IB actions give us a special kind of method, and the method that we're getting is going to be templated for us. Why they do that, I don't know. You know, it looks good. You have to implement you have a method prototype and you have to implement the method, so maybe that's why they're doing it. I don't know. But this is the implementation that we're going to work with. But we have to add in our own synthesize. So in the old days, you had a synthesized in there already. All of the code that you're going to have always goes between the at implementation and the at end. So if we're going to stick our synthesize in here, it's going to go after at implementation. So I'm going to put in, I start typing in the at symbol. And I see synthesize come up with a property. So I'm going to go ahead and select that one. For the property, I'm going to string out, I have two properties I'm going to synthesize. Actually, all I have to do is synthesize one of them. Really, because that's all I have actually is the message, the label. So I'm going to type in T because I know I called it something. And it was really called the label. And I'm going to put a semicolon at the end. So at synthesize the label, which corresponds with my property. I have one property, the label. Now I don't have to put, because this is the declaration of the data with the asterisk, when I use the data over here, I don't have to use the asterisk. I just put the name in. Once you define the data that you're going to use with that asterisk, that's the only time you use the asterisk. All the other time it stays just the name of the data. Just like pointers in C++, actually, you just refer to it by the name. Okay, are we there that far? If we do synthesize, we get setters and getters for the label because we're going to get the text, set the text, stuff like that. Okay, very good. All right, so what I'm going to do now is work with the functionality for, let's work with the text field. So what I want to do is I want to get the data that's coming out of the text field, and I think I'm going to want to write it to a string, and then I'm going to take the string and put it as a label on my label. Take the string and put it on the label. So I'm going to go into the .h file, viewcontroller.h, and I'm going to show you how you can mix and match stuff. So I'm going to put in right underneath at interface. I'm going to define an NS string like we did this morning. So I'm going to put in an opening and a closing bracket. And in between, I'm going to put an NS string with an asterisk. And I'm going to call it my text. So I have a NS string my text. Because I'm going to take the label, I'm going to take this text box here, get the text, write it to this string. So I don't have to worry about it and just use it as a variable throughout the program. So now that I have it defined, I'm going to go into, and I'm not going to do anything with it, I'm going to just do the raw text kind of thing to it. So I'm going to go into my viewcontroller.m. I'm going to go down to the text here. The text is the text I'm typing in. So what am I going to do with the text here? Well, when this method gets called, it's because the did end on exit. The did end on exit was performed, which means I typed something in there and then I pressed return. So one of the things I want to do is get rid of the keyboard. The keyboard is going to show up for me automatically. So it's called a first responder. So we have this event-driven programming environment, and we have this thing called a first responder that says if I'm text, I'm going to, it's like a dispatch unit. First responder is the keyboard. Send the keyboard out. Keyboard's needed. Keyboard shows up. Use the keyboard. So you resign the first responder to get rid of what happened originally, because I want to clean it up. So I can do that by calling a resign first responder. If I'm going to do that, I'm going to call it on this method here. Excuse me, on this object that's called the text. So I'm going to put it in an opening bracket because I'm going to call a method on an object. And the object I'm going to send it to is the text. So I'm going to type in the text. I'm going to put a space. And then I want to resign the first responder. And then I'm going to go, okay, resign, whoops, hold on one second. The text. Resign first, whoops, responder. I think I'm going to mess up with this. I am going to mess up with this because I don't have a property for it. So let's set the property. So, all right, so I can't resign it because I don't have an object created for it. So I have an action that's associated with the object, but I don't have the object. So I got to create the object. So what I'm going to do then is go back, because I left something out. And I thought about that before. Maybe I should have made a property out of that. I probably should have. So let's make a property out of the text field. We want to make a property out of it because I want to change, I want to get the stuff from it. And I want to resign the first responder from it, but it has nothing to do with what I typed inside of it, which is the action. Long story short, click on the text edit, press the control button, drag it over here, and I'm going to call this, let's see, what am I going to call this? Text, my text field. How about that? You can't call it the same as what it is. Actually, you can. Those are not reserved words. If you call it a UI text field, you're going to have an odd, in the older version, it may have changed, but in the older version, you're going to have an odd problem happen with it. It's actually going to corrupt. So don't call it the same name. What I did is I control dragged the text field because I want to make a property out of it as well. So I'm going to leave the type as text field, leave the storage as weak, and press connect. Now I have a property as well as an IB action that's associated with that text field. Did we get lost? I selected the text field and I control dragged it, press down on the control button and drag it over here. We want to create a property out of it. You want to keep your IB action, but you want to create a property. Here, let me pause for a second because this is seems to be causing confusion. This is a good time to catch up, actually. So if you haven't done the action, you click on the button, you right mouse click on the text field. You click on one of these events, and the event for the text field, the event for the text field is a did end on exit. The button is the touchdown. This guy right here on the sent event on the top is did end on exit. You control drag it over here and you get this guy over here, IB action. So did end on exit for the text field. The button, if you right mouse click, you see which one you selected, and I selected touchdown. So I'll give some people a few minutes here to catch. Alright, so now that we have a property and we have an action associated with the text field, we can continue to program the behavior for it. So I'm going to go ahead and go back into viewcontroller.m. I'm in the IB action for the text field. Now I'm going to type in the same thing before, but I'm going to type in what I called it, which was what my text, no, it was a string. The object that I haven't synthesized it. So let's synthesize it. So synthesize, I'm jumping ahead too far. You can just synthesize the last UI text field that we just added by putting a comma in there. And I think I called mine my text field. If I do that, then my text field should show up over here. So now I'm going to go back to the text method. I'm trying to program the behavior to resign the first responder on this UI text field. Now that the system knows about the UI text field, it should be able to identify it. So if I type in I see my text field shows up. Now if I go to space, I can see a resign. So what I want is this guy right here. Resign first responder. So I have my text field, which is the property that I created that represents the text field out here, space, resign first responder. That gets rid of the keyboard. So let me show you what I mean by that. If I run the project right now, oh, device locked. Well, I don't want to use it on the device. I want to use it on the emulator. So I'm going to run it on an iPhone Retina 3.5. Let's see. So if I type in the field, I see the keyboard comes up. If I press return, the keyboard goes away. If you don't put this method in here, we'll take the method out and I'll show you what's going on. If I take this method out of here and I do the same thing, and I type in here and I press return, oh, it still goes away. Okay, well, we got lucky. You don't have to put the resign first responder in there. In the older version, you had to put it in there. Now it's in there automatically. Well, that's good. Actually, that's good. But if you ever want to take the keyboard away, the resign first responder will do it. But apparently, we don't need to put it in there. It's being done automatically for us. But I'm going to leave mine in there because I like mine. All right. After I resign the first responder, I want to take the text that was typed in and copy it to my string. So my string was called my string. I believe it was called my string. So I can type in, or was it called my text? My text, I think I called it. Now it's going to be equal to, well, I'm going to run a method call here to get the text. So the text that I'm going to get is going to be from my text field. So I can type in my text field, space, text. And I can return the property of the text. And let's see what we got going on here. My text, if I spelt the, hello, there we go. If I spelt my variable correct, this is the one that's over here, by the way. My text is the string that I created. And the string that I created was here. I'm going to use it right here. This is a breakpoint, by the way. I have a really bad habit of clicking over here. This breakpoint, the program will stop if it's initiated when you have that there. So if you put that in there, you're going to say, hey, my program stopped. It's not running. It's because it's a breakpoint. It's waiting for you to respond to it. So take it out if you accidentally put it in. So now I took the string, and my text is now equal to my text.text. Well, it's text. So it's like get text, set text. We did a synthesize on this with a property, so now we can get the text, set the text. So if I wanted to set the text, I could set the text. If I wanted to do that, not necessarily have to do this, you can skip this part completely. But over here in the view did load method as an example, after I ran the super view did load, I could do this. I can do my text field, and I can go set text, and say, what do I want to set the text to, and put a string in here, and say program started, or something like that. So this is the setters and the getters I'm trying to show you from property and synthesize. So property and synthesize gave me my text field text, which is the get text, and then it's actually set text. We're going to set text to program started. So now if I run it, I'm going to say, you don't have to do this, I just did this to show you. So the text in here is going to say program started. And if I change it, and I press return, I'm not going to update this yet, but now this text here is going to copy to that string. I know that the first responder, normally in some versions of the iOS, you actually have to put the first responder in to get rid of that keyboard that's down there. But now I know that the did on end event actually is happening. So let's continue. So I can just say, actually, you know, I'm going to change this one to say, type some text here. Type some text here. Okay, half of the people are with me? More than half? Okay, good. So now we have a string, my text, and it's going to be equal to the text that's in here. So when I press the button, I don't have to use the button for this at all, actually. Let me show you a couple things. I can actually just take this label out here, the label, and set the text. How can I do that? Well, it's easy, actually. I can do this. I can say, well, my text is a string. So I can do the same logic as I just did a few minutes ago and set the label. So I type in the label, and I can go set text. Well, which string do I want to set it to? My text. Oops, not my text field. I want to set it to my text. So now when I press return, the contents of this text box is going to appear in the label. So now I run it. Let's see. Let's test it. See what happens. Program comes up. I changed it to type some text here. So I'm going to say, does this really work? Does this really work? I don't know. I guess it does. When I pressed return, again, and again, and again, but you see it's scrolling off. So what I can do then is create a multiple. So let's clean up the UI a little bit. This is totally optional. So over here I can go like this and make this a little bit bigger. And then click on the side panel to bring up the attribute inspector. There used to be a multi-line. Here it says 1. Let's make this 3 lines. And let's move this down a little bit. Move this down a little bit. And I want to get rid of this type of message because I don't want it to show up empty in the beginning. Now I'm going to run it. And we'll see if we can do some. We have 2 lines. I think I put 2 lines out there. So now it says type some text here. If you want to type some text here, then go and do it. Now I have multiple lines. So I can clean it up a little bit. I can come back over here and let's take out all these dot dots. If you see the dot dots and you don't give it multiple lines, it means that it came across, it's off the display. You only gave it multiple lines. So for those people who didn't catch the multiple line thing, in here I clicked on the label, I came over here and I changed the line count to 3. So I got 3 lines now. Anybody following me? Good. Alright, so I'm going to get rid of the side panel and come back to the code. What I did is took the text, the label, I took the label, this is the label, we had a property for it. I set the text to my text. My text was from my text field. I didn't even have to do that. I could bypass that completely by just putting this in here. So you can nest calls to calls. So if I didn't want to use my text, I could go and put it in here and nest in here a call. And the call that I'm going to put in here is my text field, my text field space text. So now I have a call with inside of a call. So rather than storing it into a string, but now I could take the string if I wanted to and do something else with it. I'm sharing the data among many different classes. Because I only have this inside of the text itself, and I'm using the label, and I'm taking my text field, and I'm doing the text. Well, I can do the same thing in the button as well. If I wanted to take all this code, put it in the button, that works too. Or in the button, I can simply maybe just do one of these calls. So I have this here. What I can do here is just set this text to something else. So I can go the label and type in set text. And let's just be smart about this. We'll just go at button was pressed. Button was pressed. So now I have the label setting the text to the button was pressed on the button event. So if I run that, I'm going to stop it because it was running in the background. And then I'm going to run it again. Now the button was pressed. Now some text was here. The button was pressed. So I can change the behavior with, let's see, I'll put hello world up here. Hello world. And the button was pressed. Not working? Okay, so what I'm going to do now is stop this video and come around and help you guys. So let me end this because this is pretty much hello world. So don't worry if you haven't gotten this far. What we're going to do is take the next couple minutes and come around and help you. But are there any other, does anyone want to voice a question to the class before I do that? Or we just want individual help? All right, so I'm going to leave this up. Let me leave this up. And let me stop this.